Okay, so what proportion is that? If it's 130, excuse me, if it's 35 divided by 190, that's equal to the sample proportion, which the formula for that is right there. So P with a little hat on his head, P hat is what that's called, it's the sample proportion, is equal to X over N, which is equal to 35 divided by 190, which is equal to, there it is, 1.1842. Squiggly equals, I suppose. Approximately. There we go. That is the sample proportion, called P hat, right? It's the number of red beads divided in the sample divided by the number of white beads in the sample, or excuse me, the total number of beads in the sample. All right, do you think that that true proportion, that of the population of beans in the big box, is close to the proportion in our single sample? Okay. Well, sure. Because we took a random sample, or we assume we did, right? Since I took it. The true proportion should be close to the sample proportion. Cool. All right, so now what if a whole class full of people took a whole bunch of different proportions? All right, let me go get some data from my actual class. I'll be right back. Okay, there we have some data from, let's say, 28 separate students or something like that. And here are the proportions for every single person in the class. Oopsie. And then I have us reminding ourselves, hey, we could make distributions from that. So the lowest, oopsie, the lowest value we have is, looks like 0.153, and the highest value, yay, I'm being silly about this. Let me go here, since I have this in a data in an Excel spreadsheet. There we go. So the lowest we have is 0.153. The highest we had was 0.267. So it said to make classes for that. Well, that's not going to be too hard to do. So we just say like 0.15 to 0.159. And then 0.16 to 0.169 and so on. Remember this from chapter 7? Bet you forgot it. That's okay. 0.18 to 0.189 and so on. Let me finish this out. There we go. There they all are. And I added some labels up here just for fun. So we have the classes just like they asked, and then we need to find the frequencies. So for example, for the first class it's 2, for the second class it's 3, the next class it's 2, 4, 1. Let's see how many are in between 20 and 209. 4 of them. 2. There's 2 here. There's none of them here. Oops, I didn't go high enough. That was my fault. There we go. Got it all filled out. So that's our frequencies. And I think that's what they wanted down here. Yep, frequencies and classes done. And draw a histogram. Well, I'll just do it in Excel. It's easier. So I've got the frequencies, I've got the classes, so I'll just highlight that data and then make a histogram, which is this one right here. Of course, the bars should touch because there's no gaps. I mean, you can't, there's no value in proportion-wise that we haven't covered. So, for example, 220, 221, 219, it's all in there. So there we go. There's our histogram. Cool. All right. Now we did that. I'm going to put this in here. Hold on. All right, there we go. I've had a little chapter 2 review of how to make a frequency table and then how to make a histogram from it. Now, what kind of shape does our histogram have? It's kind of crummy, isn't it? I mean, maybe skewed left a little bit. I don't know. No real shape at all. Maybe skewed left. But it's pretty crummy. Oops, and we're out of time, so we'll stop right there. Oopsie. I'll see you here next time.